Here we have section 2.5, exercise 44. And in this, we're told that cosine of y is equal to x. And we are asked to find the largest intervals for which y appears to be a differentiable function, or largest intervals around 0. Okay, so we'll do our implicit differentiation. So take the derivative of both sides. Derivative of the cosine is minus sine, but then multiply by that derivative of y, and that equals 1. So we have y prime is equal to negative 1 over sine y. Okay, great. Well, so in this case, we can't have y being 0 because sine of 0 is 0. And it can't be pi or something like that. So, right, so y cannot equal 0 or plus or minus pi and so on. Okay. Now, though, when would that happen? Well, we have to go back up here and try to determine that. And so we've got a couple ways to do that. One way is I can look at this and say, well, y is arc cosine or inverse cosine of x. And so as I look at that, well, what is that saying? Well, it says, cosine of here, cosine of some angle gives me x, and it says, well, if I have x that was a cosine, then what was the angle that gave that to me? And so when, what angles, so if y is an angle of 0, right, cosine of y, right, y is an angle. So if y is an angle of 0, what values of x would that work out for? So in other words, if I take cosine of y, sort of turning it around, cosine of 0 is 1, right? So if x equals 1, I have a problem. What about if x equals 0? Well, actually, I don't think that is a problem, right? So if x equals 0, then what values of cosine, cosine of what gives you 0? Well, cosine of pi over 2, right? And that sort of thing. So we can kind of work with y in the arc cosine of x function and look at what that looks like. So again, this is where graphing tools are our friends. So I'll get rid of the previous problem that I looked at with this. And, so one way we can go about it is, we solve for y and we said, oh, y equals, and let's look at our functions. There's cosine inverse or arc cosine, cosine of x, like that. And we need to move it over here a bit. But what we see is, we don't hit 0 until here at 1, and then we never have anything past negative 1, right? And then it's not defined anymore. And so there's our cosine function, and so that would say, well, we don't hit 0 until 1, so I guess coming back here, right, x, we're going to have a differentiable function here, cosine y equals x, as long as negative 1 is less than x is less than 1. So on this interval, we have a differentiable function. Now, what if I actually just graph the cosine y equals x? So let's go back there and do that. So here's, I'll put in a function here, cosine of y equals x. There's x. And notice, same darn picture, right? So let me get rid of that. Now, the difference is that here, with this implicit function, it kept going, right? It'll keep going, because basically it's saying x is a function of y, and so it does more than the arc cosine function, okay? Which is okay, because that is our actual, this one here is our actual relationship. But it doesn't give us any different answer because, once again, I'm fine all through here. This is a differentiable function. I can draw tangent lines there until I'm either at -1 x or positive 1 x, because then I get vertical tangent lines. And notice that, if x is 1, then cosine had to be cosine of what gives you 1, and 0, y equals 0, which is what we see there, is, well, that was actually nice, right? See, so you can see 1, 0. X is 1, y is 0, but then, that was a problem back here. We couldn't let y equal 0. And then we also saw that we then began approaching 0 when we had y getting close to pi over 2, or sorry, pi, right? If we go back here, right? Notice up here we're at -1 pi. And it kind of amazes me with Desmos that it does that. It's a calculator that gives you decimals and so forth most of the time, but right there, hey, it knows that's pi. Yeah, pretty amazing. But so if x is -1, we get pi, and sine of pi is 0. So we cannot let, that's a terrible looking negative sign there, we cannot let x be -1 nor 1, but everything in between is fine. So that is number 44.